I want to look at an application problem with vectors. So, as I understand it, I'm not a pilot, but as I understand it, vectors are used in doing flight paths. And so here's an example of a plane flying, but it has a wind that affects it. So an airplane is flying at an airspeed of 200 miles per hour. So that's this vector here that is orange. Headed on a southeast bearing of 140 degrees. A north wind from north to south is blowing at 16.2 miles per hour. So it's this vector here. So it's another vector that's affecting it, another component to the plane's speed. So that is blowing at 16.2 miles per hour. What are the ground speed and actual bearing of the plane? So because of the wind blowing, the plane thinks it's doing 140 degrees, but it's a bigger angle than that because the wind is also blowing it. And the resultant speeds are going to be different as well. So we are going to find both parts of this. Now let's see. I'm going to draw some pictures here and try to exaggerate this a little bit. So this isn't going to be to scale, but what we have is this is the vector, this is the real vector, and then this is that 16.2, so this is that 200. Now I want to point out that this is 140 degrees, and that's vertical, this is vertical here. So if you remember your geometry days, this is 140 degrees as well by alternate interior angles of parallel lines cut by a transversal. Okay, so that's something we do know. Things we want to find out is this side here, we'll call that x, as they have as well. So we can't use Pythagorean theorem because it's not a right triangle, but we can use law of cosines. Cosines. So that's going to be x squared equals the 16.2 squared plus 200 squared minus 2 times 16.2 times 200 times cosine of the 140 degrees. So our x squared is going to be 45,226.41, or x is approximately, the square root of that, so 212.7 miles per hour. So that is the actual ground speed of the plane. Now we want to know what the actual angle is going to be. So if I call this alpha here, we can use alpha compared to 16.2, alpha over 16.2, sine of that is going to be sine of 140, that's a 140, over x. So sine of alpha over 16.2 is sine of 140 degrees over x was 212.7. So sine of alpha will be 16.2 times sine of 140 degrees over 212.7. So alpha equals sine inverse of 16.2 times sine of 140 degrees divided by 212.7. And that's going to be approximately 2.8 degrees. So the true bearing of the plane, our theta, is going to be, make sure we didn't call theta up here. Oh, good. The actual angle is going to be the 140 degrees plus the 2.8 degrees to give us 142.8 degrees. And then the ground speed is 212.7 miles per hour. And that's it. Kind of a slow speed for a plane of that size.